Question 17 is problems on related rates. These are all real world problems. Let's do the first one. I'll do this in very detail. I'll write the given, everything in detail. For the next one, you can try it by yourselves and I will just go through the important parts. Now, first thing, read the question, understand what they have asked you. Here they have told oil spills out of tanker at the rate of 120 gallon per minute. The oil spreads in a circle with the thickness of 1/4 inches. Now remember here, whenever you have say 5 feet, it'll be given like this. 11 inches will be 2 dashes. Okay, 1 dash is feet, double dashes inches. A height of 5 feet 11 inches can be denoted like this. Now, given that 1 feet cube equals 7.5 gallons, determine the rate at which radius of the spill increases when the radius reaches 100 feet and 200 feet. Explain why the rate decreases as radius increases. Now, this one is very simple. I'll just explain you why this does. Now, imagine you have a jar of oil and you pour it in the ground. So this is you pour it on a table or a plate, a huge plate. Now you pour it in. Initially, what happens? As soon as you put, imagine there's a constant rate of volume. See, the volume is a constant rate. You pour it at the same rate, like you're not pouring once more or less. It's the same rate. What happens? It increases, increases. Initially, it increases quickly to a bigger circle, right? It becomes big. But as it goes bigger, the rate of change of radius, in the sense the circle becomes bigger very slowly. Why? Because there is too much space already, too much area in this to cover. So though the volume is at constant rate, the circle becomes slowly bigger. But initially when it was small, it becomes quicker. So what happens is, whenever the radius is smaller, if the radius is smaller only so much, the rate would be high, the increasing rate would be high. Whereas as it increases, as the radius increases, the rate reduces. That is how it works generally, everywhere. So I'm sure if you see the answers, these both answers, the rate over here, r dash, is what we need to solve, will be smaller, sorry, will be bigger for 100 feet than 200 feet. Just, you can do this experiment. Just pour some water in a plate, a huge plate, and you can see the same thing, but pour it in a uniform volume. Now coming back to the question, I hope this is clear, why I just now explained. Now how do we solve the problem here? First thing, I will tell you the conversions. They have told us gallons and inches. We need to get everything in terms of feet or feet cube. Okay, so how do we do this? So the gallon conversion, now I will write it out over here. 1 feet cube is equal to is 7.5 gallons, right? So how many feet cubes, we don't know this, will be 120 gallons. Just cross multiply it, you will get the answer. Take x to the other side and all the things over here. 1 times 120 and divided by 7.5. This would be the answer for gallons. Now, what about inches and feet? 1 feet is 12 inches. So now then, how much feet is 1/4 inch? Take this to the other side. It'll be 1/4 divided by, so this will go down. So I'll just write 1 by 12. Okay, this will be equal to x in terms of feet. It'll be 1 by 48. I hope this is clear. This is in terms of feet. We have 1 by 48 feet thickness and 120 by 7.5 feet cube of volume, rate of volume. This is the conversions. You need to know this every time. From gallon to feet cube, just divide any of this value given by 7.5, you'll get the answer. Now for this, what you need to do is, you have to just whatever you get, divided by 12 and you will get the answer. So this is one way to remember. Now I'll clear that out. Let me write the given things over here. Given, we have rate of volume. I'm not going to write it in words. I'll just write it in terms of the symbol V dash, right? Is 120 by 7.5 feet cube. That is one thing. Then the thickness. Thickness, I will write it as D, depth. That is 1 by 48 feet. And what else do we have? For the option A, radius r is given as 100 feet, and option B, question B, sorry, r is 200 feet. And what do we need to find to solve or to find? It is rate of radius. Now these are all with respect to time, okay? With respect to time, they're changing with respect to time. But I'm not gonna write bracket T all the time. We know in related rates, we always have to mention this. I'll just write over here, all the rates are related with respect to time. With respect to time T. Okay, this is the thing. Now let us start solving. Which is the formula you can use to solve over here? We know volume is rate of volume is there, so we need to have volume and derive volume to get rate, right? So let's use volume formula. Volume is what? Area times the thickness. So thickness or the depth. Okay, I'm just writing thickness here because they have told thickness. What is area? Now, which shape does it does the oil spread? It spreads circular. So area would be pi r squared, and the thickness is d depth, and that's the volume. Now we know the depth is how much? 1 by 48. So I'll just write this 1 by 48 here instead of d. I'll write pi by 48. Then we have r square and volume. Now this will be with respect to t. Here this square will be outside because this is also with respect to t. Only for this I'm going to write it. Now any more, please remember this is all with respect to t. So let us derive now on both the sides. Volume, what happens here? It is all implicit derivation. Now here, since it's only volume, just derive, it would have been 1 if it was with respect to volume, but we are deriving with respect to time. So we just write v dash of t, then that equal to pi by 48. Now this 2 comes down, 2 times radius with respect to t times derivative of that. We always add the dash, right, in implicit differentiation. That is what we are doing. Now here you can simplify. V dash would be 2 cancels over here one time and 24. So it's pi by 24 r into r dash. Now what do we need to solve for? We need to solve for the rate of change of radius, r dash. Let's leave r dash here. Let's take everything else to the other side. It will be 24 times v dash by pi r. This is the rate of radius. Now we have to just substitute what all the given values. So for the first A, we will substitute over here r dash is equal to, it will be 24. What is the rate of volume? It's given by 120 by, I'll just write by over here, 7.5. Now what is the other things remaining? Now 24 v dash is this, pi into what is radius r? R is 100. So this is it. Now r dash would be, just put in the calculator, you'll get the answer. But before that, I'll just write the second one also. R dash over here, this is for 100, this is for 200. What's gonna happen? It's gonna be the same thing, 24 into 120 by pi, but the radius here will be 200 instead of 100. So that is it. Let's solve r dash as well. Now let's take our calculators and solve. I have just substituted all the values over here. 24 times 120 divided by pi times 100 times 7.5, and the answer is 1.22. So your r dash value is 1.22 feet per minute. So for each minute, the radius changes by 1.22 feet. Now what about the next one? For 200 radius, just change this to 200 and you can see there is a decrease. We initially told, we saw that doesn't matter what, as the radius increases, the rate reduces. And yes, we can see here the rate is reducing, and that is 61 feet per minute, 0.61 feet per minute. This is how you can easily solve this problem. We got the A, B for different radius. You might get only one in the exam. But remember, explain why the rate decreases as radius increases. Because as the radius increases, the surface area is more and more volume is taken to consume. So that's why as the radius increases, the rate reduces. They're inversely proportional to each other. Even in the formula, okay, now I just told you the practical application. Now just look over here. Rate is over here. How is it related to radius? It is inversely proportional, right? So you can also like leave these are all constants, right? So let's take it as r dash equals k divided by r. So what is basically this? R dash is inversely proportional to the radius. The rate of radius is inversely proportional. So when one goes up, the other one must go down. Okay. So that is the actual technical explanation. I just realized that. Anyways, so this is how we can solve it up. You can check the answers. Yes, we got the same one, 0.611 and 1.22. Please try out this problem by yourselves. It's literally the same thing, but just the gallons over here is 90 gallons and the thickness is changed. Please try it by yourselves over here, then check the answer. Over here it's given. Okay, over here they just ask the rate of change of radius with respect to time. It's similar. Same formula, just substitution and then solving it up. Now, oil spills out of a tank at the rate g gallons per minute. The oil spreads in a circle with a thickness of 1/4 inches given the radius of the spill is increasing at a rate of zero point 0.6 feet per minute. When the radius equals 100 feet, determine the value of G. We have to determine the value of the G value, that is the volume, basically, rate of volume, V dash. Now, then, if the thickness of the oil is doubled, how does the rate increase of the radius change? Okay, this is later. First, let's do the first one, and then we will analyze it. So, what do you do over here? Let's just like what we have done. I'll do it quickly. You can write how we wrote in the first one, the given. In the first problem, we wrote given to find formula, everything in detail, right? Please do write that, and the statement also. All the rates are related with time. Not going to write it again, but please do remember. Now I'll just write volume. What is volume? It's pi r square times d. Why? Because it is in circular over here. They have given the thickness and they have told it is in terms of circle. So it is area pi r square and d. Now here, what is this in terms of, what is the inches in terms of feet? 1 by 4 inches, right? We just now did it. It'll be 1 by 48. Why? Because you just divide this by 12. When you divide it, it will be 4 times 12, 1 by 48. And volume we do not know, it is G. But leave that, sorry, we don't know volume, we know rate of volume is G. So leave volume as it is. This is not, this is known, this is not known. So write it as V is equal to pi r square into 1 by 48. Now, derive it out. V dash will be equal to pi by 48 times 2 into r dash. This is what we did. Now, what is G? G is the volume, right? Now, over here, let's write divided by G divided by 7.5. Why? Because the radius over here is in terms of feet. Now, what did we do with the thickness? We converted into feet. So this one, G is in terms of gallons, just divide by 7.5, it'll be in terms of feet cube. Okay? So V dash is G divided by 7.5. That is equal to pi by 48 times 2 times, what is the R over here? Now, rate R dash is given. R dash, this is R dash. And radius is 100. So 100 times 0.6. Now you can solve this up. You can take everything to the other side and solve it up. Let's use our calculators and solve this. Just substitute all the values. It's pi by 48 times 2 times 100 times 0.6. And don't forget that 7.5 from the other side. And the answer is 58.9. This is in terms of feet cube per minute. So all you need to write is G in terms of feet cube we are finding now. Determine the value of G. G is equal to 58.9 feet cube per minute. That's the answer. That's the option, question A. And what about if the thickness of the oil is doubled? Okay, if the thickness is more increased, how does the rate of increase of the radius change? Okay, now what happens is, I think so it'll be halved. See over here. Yeah, it'll be halved because all are constants. Now look at this equation here. Volume, let's keep only radius over here. This goes to the other side, thickness, and pi to the other side. And what happens here? It's r squared. Now these both are constants, right? These both will be constants. Now here, when you derive it, you'll get 2r into r dash. So rate is inversely proportional to the thickness. Inversely, it's opposite. So if the thickness is increasing, if the thickness is increasing, I'm telling, if it increasing, then the rate of increase of radius will decrease as thickness. And even you can think of it practically. Now if you have, say, a container and you put oil, so if the or any liquid, say for example, if you put water, it easily spreads out. Why? Because its thickness is very low. It's not viscous. It's very very thin, right? It easily flows everywhere. But now if you put honey, for example, which is viscous, the whose sort of thickness is there. When you pour it, there'll be some thickness. So as thickness is high, the rate of change of radius reduces because it takes time to flow aside, right? So that is one more thing. Now if you see over here, since all are constants, now if you're doubling this, what happens basically? D is doubled. That means you half the rate, because even over here there's a constant, go to the other side. R will be reduced by, it'll be halved. As you increase, two times, this will be halved. Let's just check the answer. So this is the answers, and the other one is just writing. You can see over here the change of radius is halved for doubling it. Otherwise, if it is thickness is increasing, you can just tell the change of radius is decreasing. That's the same answer which we got, I believe. Yes, it's feet cube per minute, 58.9. Now there is another problem. Okay, this is also interesting. I'll quickly do this one. Assume that the infected area of an injury is circular. If the radius of an infected area is 3 mm and growing at a rate of 1 mm per hour, and what rate is the infected area increasing? That's the part A. And find the rate of increase of the infected area when the radius reaches 6 mm. Explain in common sense term why is this rate larger than the part of A. Okay. So whenever they have asked you compare this, that, it's just direct, see how is it related. That is it. Now first we need to realize there's no volume here. It's not like the previous oil pouring out. It's just an injury on skin. The surface area, it's circular. It's just a surface area only. So write the formula. You need to write the given finding and everything. I'll just write the formula of area, that is pi r squared. Now I have been told over here, assume the infected area, if the radius is given and it's growing, what does that mean? That is, rate of change of radius is given over here as 1 mm per hour, right? So first we need to find, what do we have to find? What is the infected area increase, the rate of area? So we derive this A dash equals pi into 2r into r dash. A dash is what we need to solve. It's very simple, in fact, because you just have pi into 2 into what is the radius? It's 3 times 1, because over here it's 1. Solve it up, it'll be 6 pi. That's it, 6 pi millimeters, because it's all in millimeter area is squared per hour. It's not in per minute, it's per hour over here. That's it. That is the part A. Now the next one, what did they tell? They have told, if this is radius is 6, r value is given as 6. Over here r was 3, r is equal to 6. Let's solve it. Same thing, A dash is pi into 2r into r dash, right? Let's substitute. It'll be pi times 2 times 6 times 1, and this will be 12 pi mm square per hour. Very simple. Now here, explain in common sense term why rate is larger than that of part A. Why is it? Just think for a minute. It is very simple. You can directly tell over here. It's directly related, right? How is area and the rate of radius or the radius related? Directly related. So as one increases, obviously the other one increases. Over here, the radius was increased. So obviously the rate of area also will increase. Even you can think it practically, you will understand the same thing. So that is the answers. It is 6 pi and 12 pi mm square. And over here, they have given more details. It's the same thing, but yeah, you can just say even it's directly related. Any one reason, but it should be a valid reason. That's it. Or as I was showing you with the example, you can even write the example. You can see they have written so much details. You can give an example and write it out. Now we have over here about a raindrop again. The formula is different, so I'll solve this one as well. You can pause the video, try solving it by yourselves, and then continue watching the explanation. Here we have been told that a raindrop evaporates in such a way that it maintains a spherical shape. Given that the volume of a sphere of radius r is volume v is equal to 4 by 3 pi r cube, and its surface area is also given, that is 4 pi r square. If the radius changes in time, show that v dash equals, that is the rate of volume is equal to area times rate of radius. If the rate of evaporation V dash is proportional to the surface area, show that the radius changes at a constant rate. Okay, there are too many things. I read it all out, but it's better you split it out in part by part. So first thing, I realized that we need to show from this to this. We need to prove that this is equal to this, provided area formula is given. So I will just start deriving this because I need V dash. So I have to derive this, otherwise there's no way I'll get it, right? So V equals 4 by 3 pi r cube. For your exam, please write the given to find and everything, and also with respect to time t also you need to write. And here I'm just writing it directly. So V dash is equal to, derived it. This remains same, 4 by 3 pi remains same. What happens over here? It'll be 3 times r squared times r dash. Now simplify this. V dash is equal to 4 pi r squared times r dash. Now let's see what is the area. Can you see this area formula is given? Area is equal to 4 pi r squared. So now this much is A basically. So V dash is equal to A times r dash. And that is what we have been told to solve, right? Yes, see, we have proven, we have shown that V dash is equal to A times R dash. Now, if the rate of evaporation V dash is proportional to the surface area, what this means is V dash, it's with respect to time, all is proportional to what? Area with respect to time. Show that the surface area changes at a constant rate. Fine. Now, here, let's leave that area is like this only. Let's substitute what is V dash. What is V dash? We know it is area times rate of radius, right? But before substituting it, I forgot to remove the proportionality. How do we remove this proportionality? When we remove proportionality, I'm sure you have seen this in physics. When you make it equal, you put a constant and then multiply area times area with respect to t. That's it. So this is in terms of equation. So they have told it's proportional to surface area. Volume is proportional to surface area. To remove the equal to, you need to multiply a constant over here at the right side. And now I will substitute what is V dash. V dash of t is A times R dash of t. This is also with respect to time. That is equal to K into A. So area cancels. If you divide both the sides by area, that's gone. What is rate of change of radius? It's a constant of proportionality, right? K, any constant. So now this is how we have proven here, show that radius change is a constant rate. See over here we have got r dash is equal to k. So this is how we can easily prove it up. Now if you're thinking what happened here, see this is proportional. Why? Because they have mentioned V dash is proportional to surface area A. And then to remove the proportionality, you have to multiply it with constant of proportion at the right side. And over here we get V dash is equal to K times A. But we know the rate of volume is given as area times the rate of radius. So area and area on the two sides cancel. You will have rate of radius change. equals k, that is a constant value. I hope that much is clear. And we will, yeah, it's clearly explain the same thing. Now I have cancelled this a and a. I've just left r dash, but you can see over here that I've left a and a. It's the same thing. Just follow what I've written. This is more better. Okay, that's it. Now we go to the sixth one. Again, another easy problem. I highly request you all to solve this by yourselves. This is very simple. I'll just solve it over here because there's nothing much here. The forest fire is spreading in a circle with radius changing at the rate of 5 feet per minute. R dash is given, and the radius r is given. We need to find the rate of area of the burning region increasing. Area is, this is circular, pi r square. Just derive both the sides. It will be a dash is equal to pi into 2 times r into r dash. Now substitute all that you know. Pi times 2 times what is r? R is 5. Multiply this, and r dash, sorry, r is 200. R dash is 5, and this is 200 radius. Multiply here, it'll be 5 times 2 is 10, 10 times it'll be 2000, 2000 pi. 2000 pi, what is the units? It's in terms of feet, so it'll be feet square for area, rate of area, feet square per minute. So what is happening? Every minute it is increasing by 2000 pi feet square. The area is increasing. So this is how we can solve it, and you can see it's the same thing over here. It's a very simple one. Okay, I hope you remember we had done in the related rates this sort of problems. Now we will do this problem here. This particular figure is from the example 2 because I mentioned it clearly. The same situation is even used over here. So a 10 feet ladder leans against the side of a building, as an example 8.2. If the bottom of the ladder is pulled away from the wall at the rate of 3 feet per second, and the ladder remains in contact with the wall. It's in contact. That means though it's moving, it's still touching the wall. And we need to find the rate at which the top of the ladder is dropping when the bottom is 6 feet away from the wall. That means when x 6 feet away, in the sense this x is 6 feet. When it's 6 feet, what is the rate of this change? Then find the rate at which the angle between the ladder and the horizontal, this angle theta, is changing when the bottom of the ladder is 6 feet. Okay, at 6 feet, what is this angle and what is this rate coming down? Two things to be solved. Now the figure is given here. I will just write few things. The rate over here will be x dash, dx by dt. You can write it as dx by dt as well, and over here it is dy by dt, all with respect to time, or you can write it as y dash x dash. Now what is this? X is given as 6. Now from here you can find y, isn't it, from Pythagoras theorem? Let's first find that. Y is equal to what? Square root of the hypotenuse square minus 6 square. If you're thinking why, because we know hypotenuse means opposite to 90 degree. 10 squared, square of that would be sum of these two squares, x squared plus y squared. We know the value of x squared, that is 6 squared plus y squared. So take the 6 squared to the other side, it becomes minus, and take square root. This is square, right? Take square root, you'll get this. It'll be 100 minus 36. So 100 minus 36 is 64. So here you will have 8. Square root of 64 is 8 feet. Now we found y as well. Y is 8 and 10. At the situation, x is 6, the y value is 8. Now what do we need? We need to find this y dash. How can we connect all this? Same this Pythagoras theorem, isn't it? This formula itself. I'll write it out over here again. 10 square is equal to x squared plus y squared. Now derive on both the sides. Over here it's a constant, becomes 0. It'll be 2x into x dash, because we're doing with respect to time, plus 2y into y dash. What else? Now over here, we need to find y dash. Leave y, this term over here, take everything else to the other side. I'll write this first. 2y into y dash equals, this goes to the other side, minus 2x into x dash. Now only y dash is what we need. So 2 and 2 cancels. You will have minus x times x dash divided by y. This is the term. Now what next? Substitute the values which you just found out over here. X value is 6 given. X dash is also given. What is it over here? 3, right? 3 feet per second is x dash. Multiply it with 3 divided by, what is the y value? 8. So just put 8. Now simplify this. It's 3 times 4 times. It's negative 9 by 4 feet per second. This is the answer. Now we can put it in the calculator. It will be 1 times 2 times 8 and 1/4. 8 1/4 or 2.25. So negative 2.25 feet per second over here. That is the rate at which it's coming down. See, minus means it's going downwards, right? That's why, okay? So it's the top of the ladder is declining or coming down by a rate of negative 2.2 feet per second. Then what is the angle? They have also mentioned the angle, this angle theta. You can use any trigonometric function that relates these three, which theta must be there. That's it. Now I will just take sine. The reason me taking sine is because when we derive sine theta, what happens? It's positive cos, right? If I take cos, it's fine. Even tan is fine. Oh no, don't take tan because secant is very high. I mean, you can. It's reciprocal secant and all. Take sine or cos. Cos would be negative, so I'll just take sine to avoid the negative sign. Sine theta is equal to what? Opposite by hypotenuse, isn't it? So what is the opposite side? Opposite to theta is y, by hypotenuse is 10, and sine theta is sine theta itself. Now, if you're thinking, why am I not substituting the value of y as a constant value? I know it's 8, isn't it? Why am I not substituting it? If you substitute it, then you have nothing to solve with. It'll be right side equal to 0. You don't have. You need to keep something. Now we will derive on both the sides. So now the derivation of sine will be positive cos theta, that is equal to, over here it will be y dash by 10. That's it. Now what is cos theta? Cos theta is adjacent by hypotenuse, adjacent x divided by 10. What is x value? It's 6 by 10. This is 6 by 10 equals, what is y dash? Y dash is over here, sorry, theta dash is the cos theta. Oh, I forgot to tell you, theta into theta dash. Don't forget this. That is theta dash. Why are we doing this? To find the rate of the theta, right? Rate of angle. So sine theta would be cos theta into implicit derivation, it's theta dash. Here cos theta is 6 by 10, adjacent by hypotenuse. And what is y dash value? We just now found it, right? It is negative 2.24, or you can just write it as negative 9 by 4 into 10. Now this goes to the other side. So theta dash will be minus 9 by 4 into 10. And this 10 goes up and 6 comes down. So solve it up. Here you will have 3 times and 2 times. It is 3 by 4 times 2 is 8. It's minus, I'll write it over here, theta dash would be minus 3 by 8. And this is in terms of radians per second. I'll write the answer properly here. The B answer would be minus 3 by 8 radians per second. That's the correct answer. You can put in the calculator and solve it for the decimal form as well. So you can see that's how we do this problem. The first part we got was negative 2.25, yes, and the next one was negative 3 by 8 radian per second. We moved to question 8, which is another important question. I did this in my class, and one of my student, Abdullah Hussain, he solved this properly. I mean, the derivation is tricky, with the tan inverse. So he did it all correct. So I was really impressed by him. He did it on the board, so I remember this. Now we will solve this out over here. The height of this, there are two buildings they have given in the figure here. The height of the first building is 20 feet and another one is 40 feet respectively, and they are 60 feet apart. This dash indicates feet. If it's double dash, it's inches. Suppose that the intensity of a light at a point between the buildings is proportional to the angle in this figure. Now imagine the two intensities of this light. This is the angle formed. Now, if a person is moving from right to left, so from here, this person is moving from right to left at the rate 4 feet per second. Now, this is important. What is this rate? This is in terms of time. Now, you can write this as x dash. I'll write it in terms of dx by dt because this is with respect to time, right? Feet per second. What does it mean? Feet is distance x, right to left, horizontal distance. Time is because it's per second. At the what rate is theta changing from the person when the person is exactly halfway between the two buildings? Now, when the person is exactly halfway, that is 30 feet, what is this? What is the rate of change? What is the rate of change of theta? dt, the theta by dt. Now, this is what we need to solve. But we have no things over here. Everything is with respect to x, right? This is distance, distance. We don't have much things to solve directly dt by d theta by dt. So I will just tell you a formula quickly, not going in too much depth. Now, whenever you have this derivative over here, d theta by dt, that is the rate of change of angle with respect to time, by relating with two different rates. That is d theta, I can split it out, and over here dt I can write. I should have same things over here. In the sense, whatever I write over here, now if I write something, say y, it must be y over here. But now since I know dx by dt, I'll write dx. Why? What happens? This cancels out and you're going to get the same thing. But these are two different quantities, they're related. So this is the simple formula. Now rate of change, what they're asking, what is the rate of change of angle, right? Theta with respect to time. That is d theta by dx, that is dx by dt. Now, why we did this is because we can easily find d theta by dx because you have plenty of information to solve this. But dx by dt is already given. That is given 4, right? We can easily solve it up. We need to find this and then multiply by 4 and then we will get this a, exactly what they are solving for, what they're asking us. So this is the concept. Now, before that, how can we relate theta now? This is a big problem because there is nothing much you can do because it's not an enclosed figure here. It's not an enclosed polygon. We can't do anything over here like 90 degrees or anything. We have to take these two theta angles. So I will write this as theta A and this as theta B. How can we relate it? We can relate by one simple equation. The total, it's a semicircle, right? 180 is equal to theta A plus theta B. But what is theta and theta B? We need to find theta dash, yes. But theta A, I'll write it out over here, is can be related by what? Opposite by adjacent. That is tan theta. Why? Because this person is walking, isn't it? Now imagine whatever is walking, like this point, let's consider this is x. So what is distance covered will be 60 minus x because the total is given. So it's not about the person when he's at 30, it will be 30, 30 only both. But here, if we consider this distance, left side to be x and the right side will be x minus 60 minus x because this is the point in consideration. Over here, the theta is happening, right? So that means over here, theta A can be written as tan theta A, tan theta A is equal to opposite, that is 20 divided by x. Or we can also write this theta A equals tan inverse of 20 by x. This is the value. Now what about the other thing? Tan theta B is equal to what? Opposite, that is 40 by 60 minus x. This is equivalent to theta B, that is tan inverse of that thing over here. Tan inverse of 40 by 60 minus x, close the bracket. Now all you need to do is solve these both. So substitute them over here. So we know 180 is equal to theta A. What is theta A? It's tan inverse of 20 by x plus theta plus tan inverse of 40 by 60 minus x. So this is all the substitutions. Now derive both the sides. When you derive the left side, obviously it will be 0. But what about the right side? Here, this is tan inverse formula. What is the derivation? D by dx of tan inverse x. That is equal to 1 by 1 plus x squared, isn't it? So here it's going to be 1 by 1 plus x squared, that is 20 this, the whole squared. Multiplied with this again, you have to do chain rule. What is the derivative of 1 by x? I'm not going to take x to the power minus 1 and solve. I'll directly write the formula. 1 by x is minus 1 by x squared. So this is the derivation of the first one. What is theta? Now everything is with respect to x over here. So theta is derived as theta dash with respect to x. Or you can write it as d theta by dx. It's fine. Plus, what about this? It's the same thing which we just now did. 1 by 1 plus 40 by 60 minus x, the whole square. That is x, tan inverse x, right? Multiplied. Now derive this. Now again, when you derive, it will be the power rule itself. You can take this up over here and then solve it up, or I will just write it as okay. Now my bad, I just realized one mistake I did over here. I ignored the 20. The 20 remains. That is chain rule. This 20 is a constant, right? This entire thing must be solved. Only 1 by x is minus 1 by x squared, but there is 20, that's a constant. Write it as it is. Same thing here, minus 40 divided by 60 minus x the whole square and times minus 1. Why? Because there's another chain rule. See, this is done. Tan inverse is done. This x, yes, we did it. And then it's minus x, right? The denominator is done. Okay, we have done it. And then minus x derivative would be minus 1. So this remains. Now let's simplify. Try to simplify this. Right, left side is 0. So what I would do is I can just take this to the other sides. Okay. Now this one minus, see, when you multiply here, it will be minus 20 by x square and this term, right? I'll take it to the other side, it will become plus. This has a minus 1 by x squared. To the other side, it will be 20 divided by x square into 1 plus 20 by x the square. Then again, see, this is like a big bracket, okay? And over here, what happens? Okay. Yeah, here, this is minus and minus. What's going to happen? It's going to be plus, but then we take it to the other side, it's going to be minus here. So remember, this is going to be plus, but because of we are moving to the other side, it becomes minus. Whereas this one, it was minus. When we moved it, it became plus. It becomes minus. Here in the numerator, we have just 40 divided by, what do we have over here? It is this term. I will just write it out over here. That is 60 minus x the whole square. I've written it first. And this term, you can write that first, it's fine, or you can just write it like this only. You can keep these two terms separately. Now this sign goes, it'll be 40 divided by 60 minus x square multiplied by 1 by this term. It's fine, but I'm just writing it together. It'll be 1 plus 40 by 60 minus x the whole square. Now this is the this is how we solve it out over here. Now this everything is equal to d theta by dx, or theta dash with respect to x. See, that is the thing. Over here, what is the x value? See, only x is the unknown variable, and they have told when the person is what? Walking halfway, isn't it? Now just consider x is equal to half of 60 is 30, and solve it up, you'll get the answer. Let's do it in the calculator. Now I've typed this entire equation with in terms of x itself, that's fine. 20 divided by x squared times 1 plus 20 by x the whole square, then minus, here it's 40 divided by 60 minus x the whole square, bracket 1 plus, again bracket because this must be squared, right? 40 by 60 minus x the whole square, and then close the bracket. Please use the brackets appropriately, otherwise you may not get the correct answer. Now we will press calc and we will just solve it at 30. And you don't need to press plus, directly 30 is enough. The value is minus 1 by 625. And yes, that's the correct answer. Wait, let me just, okay, over here. Let's write it out over here. That is the value of dx by dt. This is minus 1 by 1625. Now, this is not over. This is in terms of radians per feet. Why? Because we did all with respect to distance x, so it's a radian per feet. But what do we want? We need d theta by dt, right? D theta by with respect to time. So this negative 1 by 1625 must be multiplied by 4, and now we will get radian per, and this feet and feet cancels, we'll get radian per second over here. Since everything is used in second, it will be radian per second. Now that will be 4 times 1 by 4 minus 4 by 1625. We can just multiply over here by 4. The answer is this. It's 0.00246. Okay, I'll just write it out over here. It'll be 0.00, it's 1 2 3, yeah, 0025. I'll write that is theta dash with respect to time. You can see radian per second. That's how we solve the first part. Now here, find the location at which the angle theta is maximum. This is simple. I'll tell you why. Because over here we need to find x, where is it maximum, right? D theta by dx we found, right? Here all you need to do is, after deriving, see, we derived this with respect to x, this make it 0. This is the critical number. We need to find x critical value, right? The same thing, only this step we have done, right? We derived it, make this derived theta dash as equal to 0. Why? Because I just write it out over here. If you have a function, say f of x is equal to 2x squared minus 3. Now, how to find the critical number, maximum or minimum? Maximum is f dash of x first, that will be 4x, that's it, 4x. And then we make this equal to 0, right? And what do? After making it equal to 0, we equate it. At x is equal to 0, it's the maximum minimum number. This is the critical number, right? Same thing, this is the equation. Theta dash is there. We make theta dash equal to 0 and solve for x. You can, in fact, entirely put this entire thing in the calculator and just solve, shift and solve, you'll get the answer. So this is how we basically solve the part A and B. I've just typed this entire equation again as it is, and over here you can see it's minus the same next part, but equals to, you can see now, is given as 0. So equal to 0. Now you need to press shift and solve and then press equal to. This is the answer. X is equal to 20. So for the question number B, you can see here, the location at which theta angle is maximum is when the x value over here, this value is 20 and other distance must be 40. So that is the actual distance. Now we have considered x to be from the left side. So this must be 20 and the other distance will be 40. Now, if at all you're not getting your answer in the calculator, just clear your calculator. You will definitely get the correct answer. And please use the brackets properly, because I had an issue. I think so. I had not put in some of the value properly at the beginning. I was not getting the correct answer. I cleared my calculator and typed it all in properly. And I did get the answer. When I press shift and solve, then equal to, you will get the answer 20. So that is how we basically solve it. It's a lengthy one. So here these are the two, this is the correct answers we got. And then over here, x was how much? At 20. So yeah, x is 20 when to be maximum, the theta will be maximum. Now we have another problem. This is also a bit different, so I'll solve this out. A plane is located x is equal to 40 miles horizontally away from an airport. So it's better we draw a figure. So it's 40 miles. Now imagine this is the airport. I'll write an airport, okay, AP. And the airplane is at an altitude of h. So I'll write this height, okay, this height, h, and this is the plane, okay, airplane. Okay, it's going to be a problem if I write airport, airplane, same. I'll just write P over here. This is the airplane, which is 40 horizontal miles away. Horizontally, x is equal to 40. Now, a radar at the airport detects that the distance s of t between the plane and the airport is changing at the rate of minus 240 miles per hour. So this distance from the plane to the airport, okay, from this over here, the rate of change, we don't know the distance, sorry, the rate of change s dash is given as minus 240 miles per hour. Now, if the plane flies towards the airport at constant altitude, the altitude is same, h is 4. What is the speed x dash? Now, this is x. We need to find the rate of speed x dash with respect to time of the airplane. Then repeat with a height of 6 miles. Then the first time over here, h is given as 4, right? For B, h is equal to 6. Option B, A, h is equal to 4. That's the thing. And based on your answer, how important is it to know the actual height of the airplane? Okay. So now first let's solve this out. You need to write the given, what to find and everything. Now, which is the formula that connects all these? It's the Pythagoras theorem, right? But before using the Pythagoras theorem, we know this is 4, this is 40. What is this distance? We can find the distance s by using Pythagoras theorem. It will be hypotenuse square will be equal to sum of these two squares. I'll take square root of 4 squared plus 40 squared. Now, 4 squared is 16. What about 40? It will be 16 and 2 zeros. So it will be 1616 square root. Okay. You can simplify this in the calculator. I'll leave it over here now. And we will use that directly. We will write the formula. I will write s squared will be equal to h squared plus x squared. Now let's derive, but before deriving, do we know the rate of height? No, it's a constant. So we are going to substitute that as 4 squared itself. Now x squared, we know the rate, so we will substitute over here. What about s? We need to find the rate as well. Now let's solve it up. It will be 2 times s into s dash, that is equal to 6. This is 0. Why? Constant derivative will be 0 plus 2 into x dash. Now, this is, we need to find x dash. So let me take everything to the other side. 2s into s dash divided by 2 into x is equal to x dash derivative. This cancels out, only remaining with the distance times the rate of change of distance of the plane and airport divided by the distance between them both, the horizontal distance. Now substitute all that we know. What is s? It is square root of 1616. Multiply it with, what is s dash? It's minus 240 given, divided by, what is x? It is 40 miles, right? Now put this in the calculator, you will get the answer. Now, when we put in the calculator, we will get negative 241.2. But we'll take this positive because this x, what is that distance? It's speed. Now, it's the speed along the x dash, rate of change of distance in the sense, speed along the horizontal distance. Now, this one over here is the rate of change of distance between plane and the airport, right? But it is constant vertically, so the speed over here is x dash, and that is what we found out, negative 241, but I'm not going to write negative, it's just 241.2 miles per hour. That is x dash with respect to time. Now then, we have done the part A, that is what they had asked us to do, the speed, that is x dash of t. Repeat this for 6 miles. Now what happens when it's 6 miles? There is simple changes over here. The s value changes. The s value will be 6 squared plus 40 squared. Now 40 is 1600 and 6 squared is 36. So it will be square root of 1636. Now all I need to do is substitute that over here. This changes to 1636. Does anything else change? No. Why? Only this, yeah, s value. Why? Because the height 6 over here is a constant. When I substitute 6 over here, 6 square, it becomes 0 when I derive. That goes off. So there is no need of changing anything. Only thing that changes is here, and instead of 1616, I'll just put 1636. And the answer is negative 242.68, but we just take the positive sign, and I will write it directly over here. B at h is equal to 6. X dash with respect to time will be 242.7 miles per hour. Now, here then, you realize there is no much difference. Now, the last, what they are asked based on your answer, what is more important? Is the height, important or no actual height? You can say it's not so much important. Why? Look here carefully. See, this diagram is not at all to scale. The distance between the horizontal distance between the airport and the plane is 40 miles. Whereas what is the height, the altitude? It's just 4 miles. Now, 4 and then it was 6 miles, right? The difference over here is just 2 miles. It's a very small difference. Now, it's like, two people are very, very far away. Imagine there is two people very far away. Now, here, if the another person stands on a stool which is say 2 feet, does it make any difference? No, not at all, because they are very far and they cannot see them properly. They'll just the height they cannot measure it. It's almost the same. But if that person is very close by, now if he stands on a stool which is 2 feet, yes, it makes a lot of difference. He goes up, right? So this distance is huge and this is very small. So therefore, in this case, that the height doesn't make any difference. Okay, that's the answer. First one was 241.2, and then next one over here was 242.7. And the difference does not make a large difference in the speed of the plane, because I told you, because the height difference is very, very small compared to the distance between the plane and the airport. And now from this problem, I would highly encourage all of you to click on the link in the description, because all these problems are explained in that video in detail. It was done in your classes. It's the example 8.3. Now this needs to be just recalled, because the next problem over here requires the same thing. Just from this, you can extract few values and solve it up. It's the same figure and everything from the example 8.3. So please watch the video in the description for this information, for this problem information, and then try solving this by yourselves, because it's all related, it's same. Now here the worked out answers are there. Please solve it by yourselves and then check the answers. And even the next one, it's again the same one, and over here please do the same thing. You can do it in different ways, okay, because over here they have used a long method. I have used the Pythagoras theorem itself. Try using Pythagoras theorem, it will be simpler. You can watch the video over there, it's explained in detail in that, and you can refer the sample answers as well. And even this question is clearly explained in the video, so I highly encourage you to watch that video. This again another very simple problem. Everything is given. All you need to do is just derive it, substitute it, and get the answers. So here, this is the worked out solution. Since the same thing is done in the video already, please watch that and then try to solve it by yourself, and then you can refer to the answers. I hope you have found these explanations helpful. Please do share it with your friends who might also benefit from it. I would really appreciate it. And please hit the subscribe button if you have not yet subscribed to my channel. Please do like my videos. If you have any doubts, comment. I will try to get back to your doubts very soon. I'll clarify them. And until the next video, take care. Bye bye, guys.